Hello friends, Shivansh this side, and today I'm going to show a very interesting sum related to zeta at 2n. And if you don't know that zeta at zeta at NES means basically 1 plus 1 by 2 to the power s plus 1 by 3 to the power s, and it goes up till infinity. Okay, so today we are going to, like, I'm not showing that what I'm going to prove, then you people run away from my channel. I mean to say that then you stop the video here. So we are going to do something interesting. So please watch till end. Please. Promise me that you are watching till end. So anyways, so what is my idea basically? That this is actually zeta at 2n, and cos x series contains something very interesting in terms of 2n, which is even contained in this thing like pi to the power 2n, 2 by 2n factorial types thing. So I'm trying to basically make a new term of this thing using this thing, so that we can get a good interesting result kind of thing. So let's start. So basically cos at pi, it's radian. Actually the radius of convergence of this series is minus infinity to infinity. So you can put any value and you will get right answer. So what is cos pi? Cos pi is minus 1, and if we are putting pi over here, we are getting minus 1 to the power, oh yes, okay, n, and pi to the power 2n by 2n factorial, and overall sigma over it. It's looking interesting. So this is the thing which is common over here, by 3 power by 2 factorial, and this is the thing which is over here as well. So what I am doing, I am extracting it from this thing. You must be thinking it's a very lame idea, that why the hell I am doing this thing, but anyways I don't know. Okay, I'm also doing one more thing. Minus from here goes up to there and plus 1, so I have whole thing. Just what I need. I have to put this bad thing out. That is something in terms of Bernoulli number. Okay, zeta at 2n by Bernoulli at 2n, 2 to the power 2n minus 1. This all goes up till here, and this terms remain now, is equals to this thing, and its sigma is equal to this thing. So basically what's our final result? It's 1 is equals to sigma n is 0 to infinity zeta at 2n upon Bernoulli at 2n, 2 to the power 2n minus 1. It's not a very beautiful thing, but it's a beautiful thing because it's rare to see a series like this term itself expressed in series, and series in series. I have one more idea regarding this, that if I do the same thing in tan x, then I can even get rid of this b2n. That's Bernoulli. So, and even this paper of mine, I shared it like 2 years back. I shared it with a Spanish researcher named Jesus Sanchez, and even he acknowledged it. So yeah, this thing is true, and I am pretty impressed by that. But anyways, I don't think it's a very big result. So one more thing, tan x expansion in closed form, and this is thing, and it's very ugly, of course. Okay, why not put this only. So this is the thing. We have to work upon. So again, an interesting fight. I hope you will like it. Anyways, so I put it on here. This is tan x, and even its derivation is very nice. If you request me, or if you even get me 10 likes on this video, I will definitely show its derivation. It's really very interesting, and I think you should know it. because it's interesting. Anyways, so this is zeta 2 and this is tan x. And actually I'm doing this thing for first time. I've done it with cos x, but for tan x I'm doing it first time. So what do we have? Bernoulli at 2n, 2 to the power 2n by 2n factorial. Oh, it's even more resembling than the previous one. It's very, oh wow, it would be a very great series. Basically what I'm doing, like if I, as it is so hard, what is this? Like this -1 is equivalent to +1. If I put as it is this thing, okay, after putting it at pi, that is it's 0. Tan of pi is 0 because sine of pi is 0 as well. So 0 is equals to it's minus plus same thing, minus 21 Bernoulli at 2n, 2 to the power 2n minus 1. So I am removing this -1 and putting 2 over. I hope it's clear. So 2 to the power 2n and x to the power 2n minus 1, and it's pi to the power 2n. That means 2 pi to the power 2n minus 1 plus 1 plus 1. So I have to do 2 by pi precisely. However, you are seeing 0 here, so it doesn't matter. So anyways, I formed this form. So basically n is 0, n is 1, sorry 0, zeta at what, 2n, of course 2 by pi as well, 2 by pi into 2 to the power 2n minus 1. You know what, it's a very interesting result, of course, is equals to 0, and 2 by gets cancelled. So okay, I don't think I should have put there n is 0 because n is not. And anyways, even if n is 0, then this term 2 to the power 2n minus 1 becomes 0, so it doesn't matter whatever I write it. Anyways, just being a disciplinary student, I should put 1. So 2 by pi gets cancelled. Anyways, so what do I mean? I mean, like, I am getting very unbelievable result, which I don't think it's even true. It means that zeta at 2n, 2 to the power 2n is equals to simply n is 1 to infinity zeta at 2n. I don't think it's true. Like, of course mathematics says it must be true. Okay, let me recheck. I think I've done something wrong. What do you feel like? This term same, Bernoulli at 2n same, 2 to the power 2n, I put 2n my here and I pushed it over here, and then pi by 2n, that means I've put here pi 2n minus 1. So basically, okay, we can even see that I remove pi from here. Anyways, I did -1 plus 1, pi over here, I pi pulled down, 2n factorial, I've managed it, 2 to the power 2n minus 1, I managed it. So basically only this thing left with zeta at 2n, only this thing. It seems it is true, but don't you think it was a very unbelievable type of result? That means if you are multiplying 2 to the power 2n with your lovely zeta function, and even if you're multiplying thing, you are getting same summation. And I would left it to you to tell me that what this is. However, it's a very easy task. Okay, let me do it for you. Anyways, what you have to do, you have to find zeta at 2n, sigma of zeta at 2n. So precisely 1 plus 1 by 2 square plus 1 by 3 square dot 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 dot. Oh, it's not very much easy. Precisely 1 by 2 4 plus 1 by 3 4 dot 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 dot, and we have to basically find sum of all these terms which would form in a grid in infinitely here and here and here and here, and it's convergent, of course. How can I prove that it's convergent? Basically I think by partial convergence by partial convergence kind of thing, because if you see series of cos x, where it is, oh shit, I deleted it, I think. Basically what I'm trying to say that it feels to be, however I haven't checked it, it seems to be convergent because Bernoulli at 2n is less than 1, and this whole thing, it is like less than cos x. Basically I'm trying to say that zeta at 2n seems to be, I'm not even sure about that. However, it's not that, I don't think it's like it was मतलब ऐसा लग रहा था कि it would converge, but however let's see. You notice I was thinking that it would be easy to prove that it is converging. Anyways, so here we get 1 infinite times divergent. Oh cool. Oh, this is a bad thing, precisely, to be honest, that this series is divergent itself. I hope you understand what I'm trying to say. Basically here I would get GP, 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 but this one is making all things bad because it's divergent. But what's happening over there, that it's, yeah, it must be divergent. That's why like we are getting this absurd kind of result, because if you are trying to do something foolishness in divergent series, it gives a more foolish things. Like for example, if you apply this result, you apply GP's result in this thing, you will get -1. But of course it's foolishness. Anyways, uh, even I am like pretty, I'm not feeling very much good. Like first of all, we found this result that if you multiply 2 to the power 2n at your zeta n, then it is equivalent to this, because it, of course it seems that it would be greater, but then we realized basically both series are divergent, so even talking on them is like a fool's talk. So anyways, I hope you enjoyed the video, and recently I made a playlist named Mysteries of Zeta Function, in which I have put already my old videos, and in that playlist you can see something very much interesting things which are very obvious, we are very simple to understand, but just a small manipulation kind of thing in zeta function, which is very interesting. So I hope you like the video, and please subscribe. It's been 3 years, like, okay, in between I have gone for a break kind of thing, for 2 years kind of thing. Anyways, but please subscribe. Okay, oh sorry. Anyways, so thank you for watching the video. So bye bye.